Ladies and gentlemen, I think it's not a secret that we are in the era of electrification. We all know that we need to hit our net zero targets, and especially here in this region, in GCC region, we're doing the right thing, deploying battery energy storage systems. In the next decade or so, we will see a deployment of a threefold of batteries worldwide, not just for electrical vehicles, but especially for battery energy storage systems moving forward. I would like to talk a little bit about how do you even get to the batteries. So if we talk about the value chain of batteries, you start in Latin America, you go to Australia, or even China, you mine the critical raw materials. Here in this picture, you see the white gold, the lithium being mined out of the ground, processed, transported to China, building all the batteries and deploying it worldwide, not just for the electrical vehicles, but especially for our renewable energies, storage of the energy, and so on and so forth. Now, what a lot of people do not talk about, by 2030 onwards, we will not have these critical raw materials matching the demand. We will have a 50% of shortage of critical raw materials. We want the batteries, we don't have enough of the critical raw materials worldwide from the mines. So this is a chance for us to really find an alternative source of these critical raw materials by using urban mining, which is, let's get all the batteries that we have been using all the years in the past and recycle them. This is what we do at Tozero. We take battery waste, recycle them through our chemical process, and specifically extract lithium and graphite, the two major critical raw materials that we don't really have outside of China's control, here locally. The beautiful thing, where does the technology come from? Novel innovation by my co-founder, Dr. Ksenia Milicevic-Neumann, which is also published on Nature. And we managed at our company to extract that lithium, and we're the very first in Europe to bring critical raw materials to our customers. The best of all, it can be cheaper. Not just cheaper, 2 times cheaper than any mine in the world, just because of battery recycling. We are 3 years old. This is how it started. This is my co-founder. We started in the lab based on 25 years of research at RWTH Aachen. It's like the MIT of Germany. And we scaled it out of the lab to industrial scale, 25,000 times of scale-up of the technology, and it works, which is fantastic. So you can see here the chancellor holding the first recycled lithium, the former chancellor of Germany, holding the first recycled lithium in Europe, which we produced, which was a fantastic moment for us. But also we have great backers. Honda invested in us. You have one of the largest engineering companies in the world from Japan, like JGC, that has been building oil and plants here in the Middle East, backing us, ready to really build the first plants around the world. This is where we are at now. We built our demo plant out of Munich. We're a German company. Once this is running, this is our chemical plant area where we're based at the moment. We see ourselves really setting up these recycling plants worldwide to break the chain of dependencies of these critical raw materials. So we are 30, 40 stellar engineers, a young dynamic team, and we're just getting excited for a new journey to really bring abundance to these critical raw materials. This is us, Tozero, miners of tomorrow, and I'm looking for partners to really join us on this mission. Thank you.
Good afternoon, I'm Alison Dring. I'm the CEO and co-founder of AmpereHour. At AmpereHour, I believe that buildings are where we should be storing carbon. Unfortunately, right now, the opposite is true. Most of the emissions in the built environment are derived from materials that are mined or extracted from our ground. So we're talking about concrete, steel, aluminum, plastics. They contribute to 40% of global emissions derived in the built environment. These materials have high emissions, so we're extracting carbon and we're pumping it into the air in the form of CO2. And they've benefited from hundreds of years of fossil economy efficiency. And so therefore, we're using them in everything. Every building tells a story about carbon. Imagine if that story were different. What if instead of mining our materials from below ground, we were mining them from the air? What if we were using materials that grow and capture CO2? Biogenic materials like wood products could cut emissions in buildings by half. But there's a problem with biogenic materials. They struggle to meet the performance standards in buildings like fire, durability, and weathering. These materials are so important, and yet they can't be put to use. And so, we continue to use fossil and mined materials in buildings. And this is where AmpereHour comes in. We've invented a technology that can lock atmospheric CO2 into material composites permanently. So we start with wood waste, and we convert it into biochar via pyrolysis. Our technology then takes biochar into material composites, and these material composites lock all that atmospheric CO2 into a high-performing material that can enter building products and store carbon for decades. We're putting that material technology to use in a facade product. This is called Sequoia. Sequoia is a cladding panel that's 100% bio-based. It has outstanding fire properties, high thermal stability. We've reached Euro Class B in fire. We have a variety of surface finishes. We can achieve any color and texture. And we're also super cost efficient to make. So this is a material that we can press into panels. Cost efficiency is important to us, and it means that we can offer the product at market product parity, and it also means no green premium. So when you compare what's out there in the building market right now with Sequoia, there's a very clear difference. You have high-emitting products like fiber cement board and formed steel products, and Sequoia generates negative 17 kilos of CO2 per square meter, decarbonizing that application by 150%. But what's more interesting is when it comes to the wall assembly. Walls make up 20% of a building's embodied carbon emissions. It's very significant. So we have one product that we change. You change the steel panel on the outside of a building with Sequoia, and you get incredible decarbonization. So much that you have not just a facade product anymore, you have a new lever for decarbonization in your building product. You can take those negative emissions and you can offset all kinds of other materials in the building project. So this is what material transition looks like. This is a dealership that we built with Audi in Germany. This is right outside Munich. We've replaced aluminum cladding panels with our carbon negative facade panels. This was our very first project. We're very proud of it. We are now operational in Berlin with a pilot facility where we're producing 10,000 square meters a year. We're looking for sustainability-led projects. If you're in real estate and you're looking for a new decarbonization lever, please get in touch with us. We believe the future of building is carbon storage, and we think that we should be transitioning from materials that emit to materials that sink. Thank you very much.
Good afternoon, everyone. My name is Ayush, and I'm the CEO and co-founder of AmpereHour Energy. Before we begin, I have a small confession. We love talking about the future. We love talking about AI writing our emails. We love talking about cars that drive themselves. But at the same time, we're trying to build the 2026 sustainable power grid on infrastructure that was built in 1926. When the power grids were being made, they were being made for a certain paradigm. You would have centralized power plants that are very predictable in nature, typically like a thermal or a gas power plant, that would then inject power into a transmission network and then would be distributed. So that would be a single directional flow of power. Your contracts would typically be 20, 25 years, and you would have a very predictable generation of energy. Now, with solar and wind coming in, that entire paradigm has completely moved. You have prosumers, you have bidirectional flow of power, you have real-time markets, and there's a need for active control and energy storage to be embedded within our power networks. Now, this is where we come in. At AmpereHour, we're not just building big batteries. We give them the smarts. We call it Elena. Elena is an AI-enabled energy management software platform. It's like a smart conductor for a very chaotic and renewable-heavy orchestra that we call our today's grid. We also build the hardware that enables to store an electron at the lowest levelized cost possible. And it's completely hardware agnostic. So in plain English, you can give us a battery that is the best battery available, and we can build out a seamlessly working energy storage system for you. Now, we've been around for about 8 years now, and we have, over the years, done about 100 megawatt hour of energy storage capacity across 10 countries. And we're in the process of doing about 2.5 gigawatt hour of energy storage. And this is for some of the leading power companies in the globe. The largest developers, the largest EPC companies, the largest enterprises, all wanting to add storage to their infrastructure. I want to give you an example of a project that we did in Delhi, which was the first regulatory-approved energy storage project within the distribution network of Delhi. This was a 20 megawatt, 40 megawatt hour energy storage system, was done in collaboration with a developer called IndiGrid and GAP. Now, this project has been live for about 9 months now, and I'm so proud to inform about the results. The system has done about 475 cycles. It has already offset about 13,000 tons of carbon. And what we see now is that you have projects like these happening across the globe. We're now doing a project that's 10 times the size, and we're doing projects through the width and breadth of the globe. We're doing projects in North America to Australia at this particular point in time. Now, what gives me hope is that battery prices have been falling over the last decade, and in my opinion, while you might have some short-term bumps, over the long run, this trend is likely to continue, and you will keep seeing more storage getting added to the power grid. We're a young, ambitious team of engineers with multi-dimensional expertise across battery, software, power systems, power electronics, and we love to work with like-minded companies on the development side, on the EPC side, utilities, wanting to add storage. To conclude, the sun is shining, the battery prices are falling, and you have the smarts available with us. If you are building an energy storage project, we'd love to hear from you, and we'd love to partner with you to build out the 21st century power grid. Thank you.